Hi there, Dr. Sheep here. Welcome back to our TGIF Talks, episode 192. I'm your host, Dr. Sheep. Joe my co-host, and I'm his Phil.
Yeah, again.
Again. Oh, I guess we're already almost there. Well. How are you?
I get through the day.
You get through the day. It sounds like you want to not get through the day. Is that true?
I'm not going to comment on that.
I see. That means yes, kids. He can't get through the day. It's a very sad life.
Yeah, well, can't all be winners.
Isn't that the truth? Well, what have you been up to in the last week?
Last week?
Oh. Well, I mean, you showed a face of like, oh yeah, I've done all kinds of shit. Where do I start?
Where do I
or is
start?
that the look of, oh fuck, I knew you'd ask that, but I never have anything to say?
Yes. Yes. Well, let's see. Monday we woke up, went to work, went home, had dinner, slept, and then started the day on Tuesday. Woke up, went to work, played some board games, went to bed. Wednesday, woke up, went to work, had to tutor some kid in calculus, went to bed.
Whoa. You tutored a child in calculus?
Thursday, woke up, went to work.
Who are you tutoring in calculus?
So our aunt has one of her co-workers' daughter. She might honestly go to the school you went to. Because they live out in town north of us, starts with the W.
Oh, well, no, probably don't go to...
They don't go there? I don't know what
They
school.
probably do not go to the same school that her daughter goes to, or I went to.
Oh. In any case, I guess she's struggling.
She probably goes to that town that starts with that name's high school.
Oh.
There's literally two in that town.
Oh, is there?
Yeah.
Okay, I guess.
One's a private Catholic school that everybody hates,
Oh.
and then one's the public school.
Oh, yeah. I guess I don't know where people go. Anyways, I guess they said she was struggling and needed help. So they asked me if I would be willing to help out.
How did it go?
I think it went all right. The problem is, one of the... I'm a little rusty.
Oh.
It's been a while. I actually messed up on one of the problems.
Oh, crap.
Well, because I was working through it, I was like, nothing is simplified. Why is nothing canceling out? And then I was at the library, and then the library closed. So I went home, and I was like, all right, I'm going to work through this again. I spent like probably 10-15 minutes working on the problem there. And then I got home. I solved the whole thing completely, start to finish, in 5 minutes. I'm like, why couldn't I do this on the whiteboard there? Because I think what had happened is I missed a sign or something, or couldn't read my writing or something. But, yeah, no. I boogered up the problem on the whiteboard when I was trying to solve it. Because I go home, I solve it on the paper, and it's just like, there's my negatives.
You look like a beautiful mind sitting there in the library working on a whiteboard.
Yeah.
What library were you going to? Oh, you have whiteboards there?
They do. They have study rooms.
Oh.
It was very small. It was a very small whiteboard. They have another study room. I'm gonna see if I can try to get in next time. That has a much larger whiteboard.
So you do this? Do you talk to her over Zoom or like phone calls?
Oh no, I met her there.
Oh.
Yeah. So.
Okay, so you're rusty, but you're improving.
I'm improving, but the question is she improving?
Oh.
It's not a matter of can I learn calculus. It's a matter of can someone else learn calculus through me.
Through you.
And well, I don't know. Maybe.
I'd say I have you reteach me calculus, but I'd probably be a little further ahead.
What do you mean?
At least I know what a derivative is.
Oh.
And I know most of the basic rules for derivatives.
Because see, they're working with the limit definition.
Oh yeah, limits. Those are stupid.
And to be honest, a lot of it. If you think about it, is kind of just algebra.
It is. I remember.
But to get things to cancel out, to get the equation you desire, it takes a bit of
finagling,
thinking outside the box. And there's some special tricks you can use to get things to cancel. Some of those I am not very familiar with because it's been a long time, and so there was another problem I was doing that was just like, man, I should know how to do this, but I could not figure it out. I scrolled through my notes and I found out the little trick you had to do. But yeah, a lot of it's kind of just algebra, but there's some, we always called it special ones. Things you multiplied by, where it's the same on the numerator and denominator, so really you're multiplying by a 1.
Oh, yeah.
But it's a special one because you're multiplying by things to get variables to cancel out. And
I think we still did that. I think we were still doing that in economics. There were some equations that required that.
And so, some of those different things I need to be more familiar with. But I don't know.
See, that was...
I hope I did a good job of explaining, because I just felt like the whole time I just felt very rusty with my skills. And then it's like, man, if I'm struggling to get through this, I wonder if they're actually learning. And because they didn't give me like the satisfying, like, oh yes, that makes sense. It was just kind of like, yeah, okay.
They might not. They might not.
It was just kind of like, okay, I get it. You know, it wasn't just like, aha. I wasn't getting the big aha moment. And so that's the thing that kind of was just like, man, I don't know if I'm doing a good job or not.
I remember limits.
It was not a reassuring thing.
I always really questioned what the fuck the whole point of the limit was. Because as we're sitting there, I'm just like, okay, why?
Method of exhaustion. As Archimedes called it, the method of exhaustion.
Limits?
Yes. So, fun fact, calculus, well, I guess derivatives, that was Newton and Leibniz. But the idea of what you're doing was known by the Greeks. Specifically, I think it was Archimedes. I don't think it was Aristotle. I think it was Archimedes. He formed his thing he called the method. And it was called the method of exhaustion. Basically, he was trying to find a way to derive pi by inscribing polygons inside and outside a circle. So
yeah. I remember. Vertasium talked about this.
Yes. So if you have a circle and you draw,
didn't he get up to like 128 sides?
I don't know. Anyways, you draw a square inside.
Yeah.
This square is bigger than the circle. This square is smaller than the circle. So you know that by you can have a defined perimeter. Define this as A, and then so now you know the maximum circumference based on the perimeter of this, and the minimum circumference based on that. Well, then he realized that, if I have a circle, and let's say now I put an octagon around it, right?
Yeah.
Something much smaller.
Close enough.
Close enough. Close enough. And then with inside that, you draw another octagon. Well, what he realized is that as the number of sides increases, the air between your upper and lower limit decreases. He called this the method of exhaustion. And so what he tried to...
It was exhausting.
Yes, you're exhausting what the circumference is, the perimeter of a circle is. And he wrote an equation to quickly calculate, well, I should say quickly. He wrote an equation...
I was going to say, this took a long time.
He wrote an equation based on the number of sides, what the perimeter would be. And it's some work to work through. It's by no means quick. Actually, yeah, this is. I think Veritas did do it.
Yeah, he did do a video on this. I remember because he was talking about how we calculate pi.
Yeah, and so then Newton came up with an even better method, binomial theorem.
Which is what we use today, isn't it?
I don't know if it is the method used today, but it was a very popular method for a number of centuries.
Before computers.
Pretty much, yeah. And so that's the method of exhaustion. That's the basic idea of limits that calculus uses. And so, I don't know, the thing that we were going through that I was, because I basically talked about how, there's the secant lines. You have a line, and they have 2 points. And you can draw a secant line, right? Ideally, you'd want to find the tangent line. Well, based on the secant line, you can get there. And so we'll call this A, and then this is some distance A plus h away. This is number h units. As h units tends to 0, you arrive at A.
Right.
And then, so then this is f of A, and this is f of A plus h. Yes. And so then, to find the slope, it's change in y, or change in
height.
Yeah, change in f of A over change in x or whatever, change in A or whatever. Sure.
I don't know. You should be using so many variables.
Anyways, where I'm going with this. So you take y2 minus y1 all over x minus x1. The a's cancel, and so now the limit as h approaches 0 is f of A
plus h minus
f of A
over h.
Over h. And this is equal to f prime of A. Should we put this in?
A convoluted way of doing a derivative.
This is the definition of a derivative. All the shortcut things that you do, the -1 from the exponent and then multiply by the polynomial, by the constant up front, all those are shortcuts based off of this. This is the definition of a limit. This is the cure-all method for a limit. Funny enough, there is no cure-all method for integrals. There is no one method works all.
I remember the quotient rule, the product rule, the chain rule. I missed chain rule, and so that completely fucked up my entire second semester. Yeah. And so I never understood the chain rule the entire time, and so I just had to give up, and I just fucking used Slater the rest of the semester because I was like, this isn't gonna work. I missed that day, and it fucked me over for the rest of the semester.
All you need to know is one little thing. The derivative, I can teach you that in like 2 seconds. Derivative.
Oh, I'm never gonna use this again.
Of x to the smiley face.
The fuck?
Just go with it, okay? Derivative of x to the smiley face.
I don't know what's going to happen here, kids. I feel like I'm going to get touched. Go on. I had to get rid of it.
Do I need to change it? Do I need to change it?
No. Continue on.
We'll make it an E. Actually, I like E better.
What? E is the worst.
I like E better.
I hate E. We're going to... X...
E to the smiley face.
No, I was talking about the smiley face. I have no problem with the X.
This equals E to the smiley face times the derivative of smiley face.
Oh, so to find the so this is, but we're finding the integral, right?
Oh no, derivative. Oh, you want to know the integral.
I thought we were talking about integrals with chain rules and product rules.
Oh, well, when you say chain rule, I think of derivatives. If you want to talk about,
oh, maybe it was.
If you want to talk about integrals,
I don't know.
then I would say parts that cycle. Parts that cycle.
I was just happy when I learned what this thing meant. And it was just a good day when I finally learned what that was. It's a very shitty
integral. You didn't even
integral.
draw it right.
I know. It's a very shitty
Actually,
integral.
you know where it came from? So...
They showed us one.
Sigma.
Oh, yeah.
The Greek letter S. Almost looks like an S.
Yeah,
Summation of area under a curve.
Some guy was like jerking off when he came up with that idea, wasn't he?
Well, I'm not going to comment on that.
What do you mean?
I do not want to know what aroused Newton.
Oh, he came up with that? He came up with the integral symbol?
I don't know. Actually, I don't know. I don't know.
Some guy, when he came up with that idea, he was just like, "This is the greatest thing I've ever done."
I know Feynman did a lot of work with integral. He came up with his own little method.
Well, Feynman would be the guy to be pleasured by such a little trick like that. He definitely, as he's sitting on his bongos going, "Yes, I see it." Yes, because, oh man, sums are...
This is the size of whiteboard I needed, though. Man, the whiteboard I had to work with, yeah, literally that big.
Yeah. Well, donate to the library and tell them to install a whiteboard that's bigger.
Yeah.
Here's $200. Go buy a better whiteboard.
Is that how much that was?
No, but I mean, that was also like
How
many
much?
years ago.
How much was that one?
I don't remember. $100 or something. We wanted to get glass, remember?
Oh, yeah.
That was going to be expensive as shit.
Yes. Okay, that's what they use in the Flash.
Yeah.
They were
So donate $500 and you can go get a glass whiteboard for the library.
Glass whiteboard.
Well, this is all back at Walmart too, because we couldn't.
Was it at Walmart?
No, we bought it from Walmart.com because we couldn't use Amazon.
Why?
Because I didn't have Amazon Prime.
Oh.
Notice how all these have women as the person selling them, no men. What does that tell us about society?
Most educators are women.
I mean, that's true.
I don't like this picture. It makes it look it makes it look white.
Go to just Walmart.com. Why are we...
Glass dryer waistboard. See, this is what I want. A full-size one. Jeez!
Well, no, remember, you also have the wheels and the... It flips, too. It's double-sided.
Well, yeah. If I were to get a whiteboard, that's what I'd want. Actually...
You're going to start saving up for a $1,500 whiteboard?